All right, welcome to your lesson on air masses and fronts. So we started off this unit with layers of the atmosphere and winds, and we talked about how weather in the United States moves from the west to the east because of the westerlies. We're going to start this lesson off with a quick overview of the difference between weather and climate. Weather is constantly changing, and it refers to the state of the atmosphere at any time and any place. Whereas climate is observations of weather that have been collected over many years and helps to describe a specific place or region. So weather is big and happens over at any time and place, whereas climate is more specific and happens over a specific time and for a specific place. All right, so air is a mixture of different gases and particles, and the air that we breathe is actually primarily composed of nitrogen and oxygen. Nitrogen is the most abundant gas in our atmosphere. We have nitrogen and then oxygen and then a mixture of argon, carbon dioxide, and some other small percentages. Air holds anywhere from 0 to 4% of water vapor, and that varies from time to time and place to place. Warm air can hold more water than cool air. And because of this, a cloudy night will be warmer than a clear night. The clouds are sort of like Earth's blanket, and clouds are the result of water condensing and clinging to particles called nuclei. The condensation nuclei can be either dust, smoke, or salt particles that are hanging out up in the air. High up, that water, when it evaporates from the ground or transpires from plants, will stick to the dust, smoke, or salt particles, and that's what makes clouds. So clouds are the world's blanket, and because of that, they absorb outgoing solar radiation and they keep temperatures warmer, so they basically hold the heat in. If we didn't have clouds, we would have. So we're getting into two main topics. We're getting into air masses and fronts, which are moving us to our next lesson on severe weather and how air masses create different types of fronts and different types of fronts create different types of severe weather. So we'll start with air mass, and an air mass is a large body of air with similar temperature and moisture characteristics. So two very key things to remember with air masses are temperature and moisture. That's what defines an air mass. Air masses form over large land or water. And here's a map showing all the different types of air masses. We're going to go through each of these. This is also review from 8th grade, from middle school science, and we're going to go a little bit deeper with each of these. So if this looks familiar, good. If it doesn't, I think it'll come back pretty quickly. So a couple of vocab words to keep in mind. If you see something with the word Arctic, it means cold. And so an Arctic air mass that's the top middle one. If you see something with maritime, those are the two on the left and the two on the right. That means an air mass that formed over water. And if you see something with the word continental, those are the two in the middle. Those are air masses that form over land. And then the second word you'll see, the second part of it is going to be either polar or tropical. Obviously, polar is going to be cold and tropical will be hot. And those are the blue and the red ones. The first letter in an air mass is always lowercase, and the second letter is capital. So the letter telling you whether it's wet or dry, whether it's maritime or continental, is lowercase, and whether it's hot or cold, which tells you the temperature, is either polar or tropical, and that's going to be capital. So as an air mass moves, the characteristics of the air mass change. And as the characteristics of the air mass change, the weather also changes in the area that the air mass has moved to, which makes sense. So if you have a continental polar air mass moving into an area that is tropical, well, the weather is going to become colder. Air masses are named according to what the temperature and moisture are like in that given area, which is what I just kind of went over with the different letters. So if it's continental, it's going to have formed over land, and if it's tropical, it will be warmer. All right, so again, tropical, T is a capital. the air mass formed over a warm area and will be warm. Polar, the air mass formed over a cold area and will be cold. Continental, air mass formed over land and will be dry. And maritime, formed over water and will be wet. And here's what happens when you put them all together. So again, the first letter is lowercase, the second letter is uppercase, which is weird because that's not at all how we write, but that's the way that air masses are designated, first letter and second letter. So continental polar, dry and cool. Continental tropical, dry and warm. Maritime polar, moist and cool. Maritime tropical, moist and warm. Here's the map again, just to give you another visual of the cold and maritime tropical and maritime polar. So the boundaries that separate two different air masses are known as fronts. And there are four different kinds of fronts. There's cold front, warm front, stationary, and occluded front. And the different kinds of fronts will determine the different kinds of weather that happen. Sometimes you can actually see a front moving in where you can see the boundary between two air masses. See if you can see in this picture the boundary between two air masses. Where do you think it would occur? The boundary between the air masses on the last slide was in the left part of the screen where you actually saw a color change in the different types of air. All right, cold front is the first one we're going to start with. A cold air mass is moving into an area that's warmer. And a cold front is shown on a weather map by a blue line symbolizing cold with triangles pointing in the direction that the cool air is moving towards. So just like with winds, fronts point to the direction that they're moving to. So the weather activity in a cold front is often violent, producing short periods of heavy rain. Cold fronts have sudden gusty winds high in the air, creating turbulence, and they create severe weather. So lots of different types of severe weather are associated with cold fronts, where you have cold air moving into an area that had warm air. Cold air is more dense, and so when it moves into an area with warm air, it pushes it over really, really fast, which pushes it up, which makes water evaporate really quickly, which creates a lot of clouds really quickly, which is what creates your severe. So here's a picture of a weather map with a cold front. You have the blue triangles pointing to the right. So this cold air mass, this cold front is moving to the right. And you've got temperatures of high temperature of 28, or high of 31 and a low of 28, moving into an area where there's a high of 62 and a low of 55. The temperatures are definitely going to get colder. This is a beautiful simulation of what happens in a cold front. So you've got the air moving over to the right, and the warm air, because it's less dense, is pushed up really fast over the cold air. And all the water vapor that is in the warm air cannot hold in the warm air anymore because it's cooling off. And it evaporates really fast, which forms those huge cumulonimbus clouds. And those cumulonimbus clouds and the stratocumulus clouds are the clouds that are responsible for heavy rainstorms and thunderstorms. So a warm front, opposite of a cold front, is when warm air mass moves into a place that's colder. And it's shown on a weather map by a red line with half circles pointing in the direction the warm air is moving. With a warm front, it usually involves long periods of light rain as opposed to short periods of heavy rain with a cold front. And it's over a larger area compared to a cold front. And you'll see why in just a second. In a warm front, the cloud formation is often very low, which creates situations of poor visibility. So that's when it's like really overcast. It's like the whole sky is really cloudy. And warm front, moving the half circles, moving into the area with colder temperatures, which will make that area warm. And so here you've got warmer air moving into a place that had cooler air. Again, warm air is less dense than cold air. So anytime you have warm air and cold air coming together, the warm air is going to rise. It just depends on which air is moving which direction. So if you've got warm air moving into a location with cold air, it's going to push up over it, but it's going to take a long time because it's less dense. And so that's why you've got a long, thin band of clouds that have dropped out water vapor. And so you've got a big, huge area that is going to have light rain. So you've got water vapor that's dropped out a little at a time over a large area, whereas with a cold front, you have a lot of water vapor that dropped out at once. So you're going to have like a lot of rain in just a little bit of an area. All right, so this slide's playing over again. Warm air rises, cold air sinks. Warm air is less dense than cold air. Cold air is more dense. And cold fronts move faster than warm fronts and have a rounded shape. Stationary fronts. So the word stationary implies no movement. When air is parallel to the front, the surface position of the front doesn't move. And it's kind of like stuck in place. And when that happens, there is light rain over a large area for several days. These are shown on a weather map with alternating red semicircles pointing away from the warm air and blue triangles pointing away from the cold air. So it's when a warm front and a cold front meet and they're just kind of stuck in place. It's almost like they can't each other. An occluded front, which is the last kind, is when an active cold front overtakes a warm front because it's more dense. So this is shown on a weather map by a purple line because when you mix red and blue, you get purple. So when you have a cold front that completely overtakes a warm front, pushes up. So here's what happens. You've got cold air moving in. You have cold air moving in, you had warm air, and then you had cold air on the other side. So it's like a cold air sandwich with warm air in the middle. And the two ends, the left and the right of cold air, pushed the warm air up. And the warm air mass is trapped between the two colder air masses and pushed upwards. And when that happens, of course, warm air holds more water. And so you've got all the water that's evaporated to form clouds. And then you've got rain over that period, over that area for a short period.